everyone. So I'm giving this a try for the first time. I hope that this is coming through okay because I'll be honest, on my computer screen it's backwards, but I think that's how it's supposed to be. I hope. Um, so I wanted to just answer a couple of questions that came through from you guys about the test tomorrow, some test review type stuff. So the first question I got was number 21 from the PST. Okay. And number 21 says, here's a function, and I don't know where this function came from. I don't know anything about it, but it's talking about the period of a pendulum, which is a thing that swings back and forth, as a function of its length. Okay. What I really want you to get used to here is just scary looking stuff and being able to sort your way through it. Because this problem, if you read here, maybe number 21 right here, gives you a G value of 9.8. Remember, this is just a unit, so we don't really need that. And then it tells me down here that I want to find the period when the length is 1 meter. So that would be my L value. Okay. So all I'm really doing here is plugging in the values that I was just given. So 2 pi times the square root of L, they told me was going to be a 1, and G, they told me was 9.8. Okay. In my calculator, I'm going to type that in as 2 pi times the square root of 1 divided by 9.8. And it says to the nearest second, this is being measured in seconds. It told me that P of L is the time in seconds. So I would just say this is approximately 2 seconds. Okay. So really what I wanted you to take away from that one is just, can you read through a problem like that and figure out what goes where? Okay. Okay. Let's see. My next problem from the PST was really 3 problems, but it all dealt with the same situation. I'm looking at 12, 13, and 14. So just to give you a second to look at the problem here. Let's see. Can I pull that out? No. So 12, 13, and 14, talking about this cone. 12 says find the volume of the cone. 13 wants to know about a domain for R. And then 14 says rewrite this equation in terms of R and B. Okay, so I'm going to go back to my paper here. Number 12 is pretty straightforward. It gives me a formula for volume. It tells me that my formula is V equals 1/3 pi R squared H. And then all I have to do is plug in the radius and the height, which I know you can't see it anymore, but let's see, it's 1/3 pi times the radius, which was 4, squared, times the height, which is 6. Okay. So when I type this into my calculator, it's 1 divided by 3 pi, and then times 4 squared times 6. Okay. And I get, as a decimal, that's like 100.53. And let's see, that's volume, so that's going to be cubic centimeters. By the way, your textbook, if you're looking at the answer in your book, they may have done this without the pi. They may have said 32 pi as an exact answer. I'd be okay with either one of those. Okay, whichever one's easier for you is fine with me. Okay. By the way, those of you that are watching, it looks like there's maybe a couple of you. Shoot me a comment real quick and just let me know that this is coming through okay. Like I said, on the screen, everything is coming up backwards. I think that's just the way my camera is set to work. So let me know that you can see this all right. Number 13 is the one I probably wanted to talk about the most here. 13 says, what is a reasonable domain for R? So let's go back to here. When it says reasonable domain R, okay, it's talking as though this R value is your independent variable, your input, and it wants to know what kinds of numbers make sense for R, okay? Well, how do I want to say this? R represents the radius. So mathematically, we could put anything we want in here. I mean, and we could put anything in and square it and then multiply by all this stuff. But when we think about it in context of the problem, and we think about this as being the radius, there are some numbers that don't make sense as a radius, right? You can't have a negative radius. You can't have 0 for a radius. You could have fractions or decimals. That would be okay. So for my reasonable domain for R, I would say it can be anything as long as it's bigger than 0, okay? Because I can't have negatives and I can't have a 0 radius, but I can have anything else. I can have decimals and fractions and all that. Okay, so this is what I would say for number 13. That's what that question's asking. Hopefully that makes sense what the question is asking. It's asking you what numbers make sense for R. Okay, and then quick 14 says rewrite the formula for H in terms of V and R. So I'm just going to jot this quick. Rewrite for H in terms of V and R. Okay, so that's referring back again to my original formula. 1/3 pi r squared h. And we want to try to get the h by itself. Okay, oh, you can't see what I'm doing, can you? There we go. Okay, so to get h by itself, the first thing I would tackle is that fraction. And remember, we really don't want to divide by fractions in a situation like this. So I would take that 1/3 and get rid of it. Let me grab a different color here. I would multiply by 3/1, or just 3, right? Because 3/1 is just 3. The reason I'm doing that is that'll cancel out that squared all in one shot. Divide by pi r squared. Cancel and cancel. And we are left with h equals 3v over pi r squared. And that's what that answer was looking for. Okay. So those are the specific questions from the PST that were submitted through the Google form. I'll say this real quick, that if you're watching this and you're thinking, gosh, there was another question that I wish I could ask, you're always welcome to throw them in the comments. You also can go ahead onto Blackboard and submit them through the Google form that I posted there. I'm going to do another one of these live streams during my 6th-hour class, but then I would make sure to address those questions then. Okay. The other more general question I received last night, talking about domain and range. Okay, and so I sort of put this together to start talking about it. Is this is a hard concept like forever and ever. Okay. Yep, I'll come back to 9 and 11 on the PST in just a second. Domain is always asking you, what are the possible values for x? What numbers can you put into your function? And then range is your possible values of y. What answers can you get back out? So functions can show up in a lot of different ways, and I just did 2 examples here. But when I have ordered pairs like this, you can see the entire function. This function consists of 4 pairs, right? And so as far as my possible values of x, this is a finite list. These are my possible values of x. And so for my domain, I would just say, let's see, and you're supposed to put these in order. I probably wouldn't mark it down if you didn't, but I would say 1, 2, 4, and 9. Those are, in this function, those are my only possibilities for x, okay? And for range, my only possibilities are 3, 7, -5. And then 7 again, remember, it's okay if the numbers repeat in the range. So when I list these, I don't have to list the 7 twice. I can just say -5, 3, and 7. Those are my possibilities for range. Okay. It gets a little bit hard when you get something like this, y equals 2x squared, because this really represents like an infinite number of ordered pairs, okay? I mean, I could plug in a 1, for example, and 1 squared is 1, so 2 times 1 would give me 2. I could plug in a 3, and 3 squared is 9, 2 times 9 is 18. I could plug in a -4, Negative 4 squared is 16. 16 is 32. But I hope you're seeing that I could keep doing this forever and ever and ever and ever, okay? Because I could keep coming up with x values all day long. So when I say what are your possible values of x, I can't just list my numbers because it would go on forever. But think about what I was just doing. Is there anything that I couldn't just pluck out of thin air and put in for x? And in this case, there's really no restrictions because I can put anything in for x, right? And get an answer out. So for my domain here, because I wasn't limited in what I could choose for x. I could choose anything I want. I would say all real numbers. And that is a little bit more abstract to think about. You have to think about, every number you could ever think of. Is there anything that you couldn't put in for x there? And as tough as that is, I actually think range is a harder question at this point in the game. Because range wants to know what kinds of numbers will I always get out for y, okay? And I want you to notice something, that when I plugged in positive numbers, I got positive numbers back. When I plugged in negative numbers, I got positive numbers back. I think the smallest I could ever make my y value is if I were to plug in a 0 for x. 0 squared is 0. 2 times 0 is also 0. So 0, 0 is like the lowest point I can come up with. If I backtracked from 0 and did negative 1, what I'm going to run into is negative 1 squared is positive 1. 2 times 1 is 2. And you'll notice I get a positive 2 just like I did with the positive 1. Okay? Still a function. That's still okay. But if you look at all of my y values, do you notice that they're always positive? So for my range, I would say I can get any answer I want that's greater than or equal to 0. And be careful, we don't want to just say positive numbers because that doesn't include 0. Okay, positive numbers don't include 0. But greater than or equal to 0 would work perfectly there. Okay, I am a little short on time here. I'll tell you what, I will get 9 into this video, question number 9 from the PST, and then I will tack number 11, because these came through on the comments. I will tack number 11 onto my next video. So if you either tune into that one live or you'll be able to watch it later too, I'll post the link for that. I'll do number 11 there. Okay. So number 9 says 4 times 3x minus 8 equals 11. I might be tempted to divide by that 4 right off the bat, just to get rid of it. But the problem is when I divide by it over here, I can see it's not going to work out very nicely, right? So this is probably one where I would just go ahead and distribute because it's not doing me any favors to divide by 4 right now. So I have 12x minus 32 equals 11. Okay. Add the 32 to the other side. And so I have 12x equals, let's see, 43. Yeah, this one's going to be gross no matter what. Because now I'm going to divide by 12. Divide by 12. And this is going to come out to be a decimal. So if you're just thinking you got it wrong because it came out to be ugly, your answer is probably right. This is what I got. 3.583 repeating. Okay. So I would say x is equal to 3.58 maybe, if I'm rounding. Okay. Yeah, I wish I had given you nicer numbers on that one, but stepwise, that's how I would go about it. Okay. Like I said, you could have also divided by 4 here, and that would have just made this a decimal from the beginning, and then add 8 and divide by 3. You still would have come out with this gross answer. Okay. Okay. Well, thanks to those of you who tuned in today. I start my next live video with question number 11. Okay. And feel free to text or email or whatever if you're having questions about anything else before our test tomorrow. All right, let's see if I can shut this thing off.